This is the world's simplest solar tracker. It'll always try and point directly towards the sun. It could do this without the need of any computer chips, computer programs, programming. The only condition is that it needs to be in direct sunlight. It could do this with just 3 components: the solar panels, the base, and an electric motor. But how does it work? And how is it so simple? We start with 2 solar panels. And the real magic is how we wire these 2 solar panels to this electric motor. We'll attach 2 black wires to the negative side of the motor, and 2 red or orange wires to the positive side of the motor. And now we'll solder on some wires to the solar panels. We'll use black for negative and the warm colors for positive. The base is simple. There are 2 parts, a stationary part and a part that moves. The part that moves holds the electric motor and the 2 solar panels. The stationary part is where the motor shaft is inserted into. Now let's get back into the magic of the wiring. When you attach a solar panel to a DC motor, the DC motor will spin in a certain direction. But if we flip the wires, the DC motor will spin in an opposite direction. Here you can see the motor changing direction when the wires are flipped. Now this is where it becomes really cool. Instead of using 1 solar panel and switching the wires, we could actually use 2 solar panels wired in reverse. So when this solar panel is in the sun, it rotates this direction, and when the other solar panel is in the sun, it rotates the other direction. If both solar panels are in the sun, there's no motion because the voltage is cancelled out. Here's my first attempt at trying out the world's simplest solar tracker. You can see it's oscillating way too much. It's almost working, it's kind of pointing towards the sun. I'll fix this issue of the oscillation, but it does provide a good example for how it works. If we pause here, you can see the sun is only hitting this solar panel. This will cause it to want to spin in this direction. When it's facing this way, the sun is only hitting this solar panel, causing it to want to rotate the other direction. At first I thought it was oscillating because the angle between the 2 solar panels was too much, so I tried to reduce the angle. I made a special piece that allows me to change the angle of the solar panels. As you can see, it still oscillates, and I found out that it's not the angle between the solar panels, it's actually the speed of the motor that matters. The motor is too fast, so it's overshooting the neutral point. This was a fairly easy fix. All I had to do was find a 10 RPM DC motor. By using a slower motor, the contraption doesn't overshoot the neutral point, where both solar panels are facing the sun. And now you can see the world's simplest solar tracker working perfectly. There are some engineering solutions that are just so simple that it's really just amazing. This works independent of location on the Earth. There's no internet needed, no programming, no software, no control board, nothing. Just an electric motor and some solar panels. Here's a time lapse of it working throughout the day. You can see how it's not rotating perfectly smooth, and this is because the DC motor requires a minimum voltage to rotate. Basically, 1 solar panel has to overpower the other solar panel just enough to get the DC motor to spin. I hope you enjoyed this video, and I hope you learned that sometimes the best engineering solutions are the simplest. Thanks for watching and happy printing. If you liked this video, check out some of the other videos that I've made. If you want to make this project yourself, you could find the STL files on my website for free. And if you want to support 3D Printer Academy so I can make more videos just like this, then click the join button below. Once again, thanks for watching, and I wish you the best on all of your projects and future endeavors.